Ever wondered how I made my slime jiggle so smoothly in Scratch? Well, today I'll be showing you how I did this, and by the end of this tutorial, you should have a slime platformer with scrolling levels, slow motion effects, spikes, sounds, and more. So like, subscribe, open up Scratch, and we'll get scratching. So every project I make always starts with ThinkingPlanely's project controller. It contains a lot of features like a cover that automatically disappears after everything in the project setup is finished, a project stop broadcast that is broadcast when you hit the stop sign, and a lot more. So go to ThinkingPlanely's project controller project and backpack or download all the sprites. Then create a new project and add the project controller sprite to it, and rename the default sprite to player. So to make our platformer, we're first going to need some basic physics before we add the slime effect to our player. So first, just for debugging purposes, we will hide the project controller sprite. Okay, now go to the player sprite and add when I receive project start, forever change y by -1. Now when you run it, you can see that it sort of looks like the player is falling, but not quite. If you've seen objects fall in real life, which I hope you have, you'll notice that they fall faster the longer they fall. So to make this happen to our player, it's actually pretty simple. Just create a local variable called _y velocity and change that by -1 in the forever loop. Then change this to change y by y velocity. Drag the sprite back up, hit the green flag, and it should fall and get faster just like in real life. Now if you stop the project, drag the sprite back up again, hit the green flag again, it will jump down at the bottom of the screen. So add when I receive project setup, set y velocity to 0, and that will fix that. So what's the difference between project start and project setup? Well, the project controller first broadcasts project setup and waits for all the receives to finish. So this is where you should put all your setup code that runs once. Then it broadcasts project start and fades the cover away immediately. So this is where you should put all of your loops. Okay, now that we got our player to fall correctly, we need to make it collide with the ground. That we also have to make. So add a new sprite and draw a box for the ground. Then go back to the player sprite and at the end of the forever loop, add repeat until not touching ground, change y by 1. Now this by itself will, clip through the ground and jump around funny. So to fix this, we need to put the repeat until in a custom block called update, with run without screen refresh turned on. Put update at the end of the forever loop, that will fix the clipping problem. And just so all the physics code is in one place, we should just go ahead and put all of this in the update block. Next, we'll add some simple controls to our player. So before the update block, add if key up arrow press, then set y velocity to 10. This will make the player jump, and to make the player be able to go left and right, we need to first make an x velocity variable, and in the update block, add change x by x velocity right after the change y by y velocity. And then duplicate this and change it to key right arrow press, and change this to change x by 1. Duplicate the if again, change it to key left arrow, and change it to -1. Then just so it gets reset when you click the flag, add set x velocity to 0 in the beginning of the when I receive project setup. Now we can control our player, but as you can see, we need to make it run into vertical walls and not just jump to the top of them. So instead of just changing y by 1 when the player hits the ground, we need to change both x and y to make the player move back towards where it previously was. We first need to get the normalized x and y velocity. Normalized meaning the direction of the velocity doesn't change, but the greater value is reduced to 1. Easiest way to do that is, if abs of y velocity is greater than abs of x velocity, then set normalized x velocity to x velocity divided by abs of y velocity. Duplicate this, change it to normalized y velocity, and this to y velocity. Then duplicate both of these and put them in the else, and change it to divide by abs of x velocity. Now, in the repeat until, add 0 minus normalized y velocity to the change y by block, and duplicate it, and change it to change x by 0 minus normalized x velocity. Now our player will actually run into the wall, and not just jump to the top of it. But we can now no longer move on the ground. So to fix this, we need to, after the player backs out of the ground, change x by x velocity, but only by the amount it needed to move out of the ground. So we first need to get how far the player went into the ground as a factor of the player's velocity. So in the if abs of y velocity is greater than abs of x velocity, add set overshoot step to 1 divided by abs of y velocity. And in the else, add set overshoot step to 1 divided by abs of x velocity. Then add set overshoot to 0 before the repeat until loop, and inside it, change overshoot by overshoot step. Then wrap this whole thing in an if touching ground, and at the end of the if touching ground, add change x by x velocity times overshoot. Now the player will slide smoothly across the ground with 0 friction. And to add friction in, it's pretty simple. All you have to do is first create a friction variable and set it to something like 0.1, then just add set x velocity to x velocity times 1 minus friction for the change x by block. But this now totally wrecks what we did earlier, and you can clip through walls again. This is because instead of just changing x by x velocity times overshoot to allow the player to slide, we need to move the player in a parallel direction to the current contacted slope by the parallel velocity of the player times overshoot. So first, we're going to need to get the slope, and in this case, we'll just do it an easy way and only detect angles in 45-degree increments. So to do that, first we need to go over to the costume editor and make our player a rectangle 64 by 40 pixels in size and rename it to hitbox. We'll add the visual detail to our player later. Also make sure to convert the costume to bitmap, otherwise weird things will happen when we try to detect the slope later on. To detect the angles though, we need 4 more costumes, 1 for each side. So duplicate the hitbox costume and rename it to top. Then delete the bottom half of the rectangle and add a 2 pixel line to the top. Repeat these steps for each side. Okay, so to get the slope using these costumes, we'll store what sides are currently touching the ground in a byte-wise flag in a variable, and use a lookup table to get the angle. So go back to the code tab, and right after the repeat until, add set slope to 0, switch costume to left, if touching ground, then change slope by 1. Duplicate the switch costume and if, and change it to switch to right, and change slope by 2. Then do the same for the top, change it by 4, and the bottom, change it by 8. Make sure at the top of the update block, you add switch costume to hitbox. Now create a list called slope LUT, LUT standing for lookup table, and for the values, it'll take way too long to explain each one of them, so just either pause the video and copy them from here, or download the file in the description and import them into the list. Okay, now at the end of the last if, add set slope to item slope of slope LUT. Now that we got the angle of the current contact slope, we need to get the parallel velocity of the player to the slope. So after the set slope, add set velocity to square root of x velocity times x velocity plus y velocity times y velocity. Next, we need to get the angle of which the player is moving using atan2, which Scratch doesn't have, so we'll have to make one ourselves. But what is atan2? Well, it's basically just a function that calculates the angle from 0, 0 to xy, and at the core is really just atan of x divided by y, with some ifs to make it work correctly with negative values. So create a new block called atan2xy arrow tmp, and inside it add if y is less than 0, then if x is less than 0, set tmp to atan of x divided by y minus 180, then stop the script. Then duplicate both of those and drag it under the if x is less than 0 and change this to plus 180. Then duplicate just the set block and drag it underneath the if y is less than 0 and remove the plus 180. Okay, so now on the update block, add atan x velocity y velocity after the set velocity block, and to get the parallel velocity, add set parallel velocity to velocity times cosine of slope minus tmp. Then change this to set x velocity to parallel velocity times sine of slope times 1 minus friction. Then duplicate this and change this to y velocity and this to cosine. Now duplicate the change x by block and change it to change y by y velocity times overshoot. Now the player should be able to run into walls and even roofs if we have them. But the costume glitches all around funny, so we'll fix that later. Right now, we're going to fix being able to jump midair. So go over to the Costumes tab, duplicate the Hitbox costume, and rename it to Jump Hitbox. Select everything from the top all the way down to the first checker, and delete that. Then draw a 4 pixel line on the bottom and the 2 sides. This will allow the player to wall jump. Now go back to the code tab and add switch costume to jump hitbox to the top of the forever loop. Then put all the player's controls into a if touching ground block right underneath the switch costume block. Make sure the update block is outside of the if though. Now we're done with the basic physics. Or are we? Well, no. We still gotta fix one more glitch. If the player is against a corner and you jump and move at the same time, it will sometimes go to the edge of the screen and get stuck there forever trying to move out of the ground that way. This is due to a precision error, making it move back slightly more than it moved in and skip over the part where it wasn't touching. We can't 100% fix this glitch, but we can somewhat fix it by storing the last position it wasn't touching the ground after it backed up, and then going to that if the repeat until is backing up more than it went in. So to do that, first add switch costume to hitbox. If not touching ground, then set last X to X position and set last Y to Y position to the end of the update block. Then add or not overshoot is less than 2 to the repeat until and put everything after the repeat until in an if overshoot is less than 2 else block. And then in the else, add go to X, last X, Y, last Y. Okay, that'll fix that glitch. Now we're done with the physics. Right? Well, no, we still need to add in delta time. Why? Well, by default, Scratch projects run at 30 frames per second, but in TurboWarp, you can run them at 60, 120, even 160, or pretty much any frame rate you want to make the gameplay look smoother. For most projects, though, it makes everything move faster and pretty much unplayable, but by adding delta time to the movement, it will make everything keep a consistent speed no matter what the frame rate is. Delta time is the lapse time since the last frame, so we multiply how far we want to move the sprite in 1 second by delta time. But how do we get delta time? This is when ThinkingPlanely's project controller comes in use again. Just add the timing sprite to our project, and delta time is this variable right here that automatically gets updated every frame. So in the player sprite, add times delta time to the change y velocity block, both the change x and change y blocks, when you're setting the overshoot step variables, and in both of these change x and change y blocks. Now if we run the project, it's really slow. This is because the current acceleration is now only 1 pixel per second squared instead of 900 pixels per second squared. So to change that back, we need to change this to -900, and the controls change this to 300, this to 30, and this to -30. For convenience, we'll make two variables called game y gravity and game x gravity. Add game y gravity to here, and duplicate this, changing it to x velocity and game x gravity. Now gravity in real life is around 9.8 meters per second squared, so we should set the game y gravity variable to -980, so each pixel looks like 1 millimeter. Okay, now that we're done with the physics, we can get to work on morphing the player. So to explain what we're going to do, I'll first open up a blank project. Now we could try making a big bunch of costumes for each position to morph the player that way, but that would take a lot of work and it would look pretty chunky. So the other way is to use the fisheye effect block. But how can this help us morph the player? Well, how the fisheye effects works is it bulges the pixels from the center out towards the edge. It does not affect any in the corners because it only affects stuff within the biggest ellipse that fits within the sprite's bounding box. And if you look at the bottom, it looks like we're squishing the bottom dango. But we don't want to be able to see the other dangos or the skewer, so delete them. But now it doesn't look like we're squishing the dango anymore. This is because when we did that, it changed the bounding box. So to make the bounding box bigger again, we can just draw a rectangle around the dango, move it so the bottom of it is at the bottom of the dango, and make it perfectly clear. Now, this is looking good, but what about the sideways morphing? Well, we can use Scratch's whirl effect, which whirls the sprite around the center of its bounding box. And since the sprite's bounding box is up here, it will look like it's skewing the dango instead of whirling it. But is there an accurate way to morph a specific pixel on the sprite to a specific location? Well, actually there is, using these equations, which I got by inverting these equations from Scratch's source code. So first create a new variable called bounding box radius, then create a new block called morph point at y, y1 to x, x2, y, y2, and inside it add set TMP to 1 minus square root of x2 times x2 plus y2 times y2 divided by bounding box radius. Then set whirl to 0 minus a tan of x2 divided by y2 divided by TMP times TMP. Then set y to y2 divided by cosine of whirl times TMP times TMP. Then ln of 1 minus 1 divided by bounding box radius divided by y1, divide that by ln of 1 minus bounding box radius plus y divided by bounding box radius, put that in a -1 times 100, and set the fisheye effect to that. Then set whirl effect to whirl, and that will complete the morphing block. So now that we got the block, we can backpack the sprite. Make sure you backpack the sprite and not the block, otherwise local variables will not work properly. Head back over to your platformer project, then drag the sprite out of the backpack, drag the block into the player sprite, make sure to delete this sprite, then go over to the costumes tab, duplicate the hitbox costume, rename it to player, convert it to vector, then make a box, make sure to hold shift while dragging so it's a square and not an oblong rectangle, then set the stroke and fill to none, and resize it so it shows 160 by 160 under the costume name. Then snap the bottom center of it to the bottom center of the player, and go back to the code tab and set the bounding box radius variable to half of 160, which is 80. Then at the bottom of the update block, add switch costume to player. Now, create a variable called top y offset and set it to 40, which is the height of our player. For now, we'll just morph the player to the mouse position. So add morph point at y top y offset to x mouse x minus x position, y mouse y minus y position minus bounding box radius, to the end of the update block. And for efficiency, add clear graphic effects to the start of the update block. Now when we run our project, it should morph the top of the player to our mouse. Well, unless we move the mouse too far off over here. But that should never happen once we add physics to the top, so we could ignore that. So to add physics to the top part of our player, we're first going to need two variables, underscore top x and underscore top y, and replace the mouse x and mouse y blocks with them. Then duplicate the change x velocity and change y velocity blocks, and change them to change top x velocity and change top y velocity. Then, just like we did in the sprite itself, add change top x by top x velocity times delta time, and change top y by top y velocity times delta time after this change y by block. And make sure to set top x velocity and top y velocity to 0 at the end of the project setup block. Now, this by itself won't do anything too exciting, since the top is just going to fall indefinitely down. So to give it that jiggly slime effect, we'll attach the top to the base using the damped spring equation, mass times acceleration plus dampening times velocity plus stiffness times value equals 0. We need a block that gives us the acceleration based on the other values. So make a block called getAcceleration of spring with value, velocity, velocity, dampening, stiffness, arrow TMP. Then inside the block, add set TMP to value times stiffness plus velocity times dampening, and put that whole thing into times delta time. Now, let's first add the spring to the y-axis. So in the update block, under the change top y velocity block, add getAcceleration of spring with value top y minus y position plus top y offset, velocity top y velocity minus y velocity, dampening 3, and stiffness 400. Then change top y velocity by 0 minus TMP, and change y velocity by TMP. And make sure in the controls you change the amount it jumps to something bigger like 700. Now when you run the project, the top should jiggle up and down when you jump. And to add the sideways jiggle, just duplicate the getAcceleration, change top y velocity, and change y velocity blocks, and change this to top x minus x position, this to top x velocity minus x velocity, this to 1, and this to 70. Then make sure these are top x velocity and x velocity. And when you run the project, the player should jiggle and act jello slime-like. Now, platformer isn't really fun if there isn't any dangerous things to run into. So next, we're going to add some spikes to our level. So first, duplicate the ground sprite and rename it to spikes. Go to the costumes tab and draw a spike or two in the level. Then make sure to delete the ground from the costumes. So now go back to the player sprite, switch back to the code tab, then in the forever loop under the update block, add if touching spikes, then broadcast game reset level. Then up here, change this to when I receive game reset level, and then at the end of it, go to wherever the starting level is. In my case, it's x negative 30, y 0, set top x to x position, and set top y to y position plus top y offset. This will make sure the player goes back to a starting position when you hit a spike. Now when you run the project and hit a spike, it should reset the player back to the start of the level. Now it's time to make it switch to the next level when we reach the end of the screen. And that's pretty easy. All you have to do is at the end of your forever loop, add if x position is greater than stage max x, then change game level number by 1, and broadcast game reset level. Then add when I receive project reset, this is called when you're holding the R key down while pressing the stop sign, set game level number to 1, broadcast game reset level. And in the ground sprite, add when I receive game reset level, switch costume to game level number, and also drag this into the spike sprite. Then you can create a new costume in the ground sprite, draw another level, drag this over to the spike sprite, add spikes, make sure to remove the ground from the spikes costume, and now when you run the project and hop over to the other side of the stage, stage is to switch levels and go to the next one. And to reset it back to the first level, just hold the R key down and press the stop sign. Type Y into the ask prompt, hit enter, and it should reset back to the first level. This is what you would do before saving the project to scratch. Now, if you've noticed, the player jumps a little weird right now. This is because we are only applying an impulse to the bottom of their player and applying none to the top part. So to improve the controls, let's first make a new block called impulse by XX, YY at Y factor, Y factor. Then inside there, add change x velocity by x times 1 minus y factor. Then duplicate this and change this to y velocity and this to y. Then duplicate both of those and change them to top x velocity and top y velocity and remove the minus block. Now in the if key up arrow pressed block, replace this with impulse by x0, y800 at y factor 0.8. This will make it, instead of just applying impulse to the bottom, it will apply 20% of the impulse to the bottom and 80% to the top, making the jumping look a lot more realistic. Then do the same thing for the sideways movement. Replace this with impulse by x100, y0 at y factor, and let's just say 0.25. Then duplicate this and replace the block inside the if key left arrow pressed block with it and change this to -100. Now both jumping and moving should look a little less weird. But as you can see, if we were to jump while touching a wall, it will shoot up really fast to the top and way too high. So to fix this, we need to, once the player jumps, not allow the player to jump again until either they let go of the up arrow or until they've been in the air for over 1/10 of a second. And while we're fixing that, it will also fix another problem, and plus it will also add coyote jumping, meaning that you can jump or move if you touch the ground in the last 1/10 of a second. So first, add set last time on ground to timer to the start of the if touching ground block in the forever loop. Make sure it's the timer variable and not the one in the sensing category, as that will not work since the project controller resets the timer every frame to know when you hit the stop sign. Then move everything else in the if into a new one, if timer minus last time on ground is less than 0.1, and make sure to put this if outside of the if touching ground. This will make the player be able to jump as long as it's touched the ground in the last 1/10 of a second. Now change this to an if else, and in the else, add set did jump to 0. Put if did jump equals 0 around the impulse block, and inside it add set did jump to 1. Then in the else of this if, add set did jump to 0. Now if we jump while touching a wall, we won't shoot up crazy high. Then also do the same thing for the sideways controls, and add set did move to 0 in this else, and wrap this impulse block in if did move equals 0, and add set did move to 1 to the start of it. Then duplicate this if and wrap this impulse block in it. Then add if not key right arrow pressed or key left arrow press, set did move to 0 to the end of this if. So, we want to be able to add decorations to our level, like grass, without changing the physics so the player can go behind the grass. So to do that, first duplicate the ground sprite and rename it to level. This is the sprite that we're going to see, so we can add grass and stuff to it. Now in the ground sprite, add when I receive project setup, set ghost effect to 100, and drag this into the spike sprite as well. This is so you won't see the colliders, but the player will still be able to collide with them. So now go to the spike sprite and copy the spikes from the costumes into the corresponding costume in the level. This is so we will actually see the spikes instead of just randomly resetting with no idea on what we hit. Now let's make our player look more slime-like. So go to the player costume in the player sprite and redraw the box, because this was actually an image since we converted it from a bitmap earlier, and then delete the image. Then switch to the reshape tool, and at the top center of the box, click once to add a new control point. Delete the other 2 points at the top corners, then drag the handles of the top point to the same width as the slime. Now click again at the bottom center to add another control point, and move it down slightly, and drag the handles to the same width as the slime. And drag the outer 2 control points up a little to more even out the bottom. Then to give it a more transparent look, go over to the fill and select the radial gradient. Set the opacity of the inner color to about 90% and change the hue to whatever you want. Then in the outer color, set the hue to approximately the same color as the inner color, and set the opacity to like 50%, and turn the saturation down a little bit. Now a lot of you might not know this, but you can actually adjust where the center of the radial gradient is with the paint bucket tool. So click on the paint bucket tool, and click somewhere on the slime to make it look like there's a light source coming from a specific spot. We can also add a reflection by adding an oval right above where the center of the gradient is, set the fill to a radial gradient, change the inner color to white with about 90% opacity, and the outer color to perfectly transparent. Then rotate it slightly. Now let's make the background look more sky-like. So go over to the stage and draw a box to fill the stage. Then set the fill to a very slight greenish blue, around 60, and turn the saturation down to around 70. Then select vertical gradient, change the bottom color to 60, the same as the top color, the saturation to something around 40, and the brightness to around 90. So now you've got a cool looking platformer that you can show off to your friends. To make it even cooler, stay tuned for the next video where we'll be making the top of the player collide, add scrolling levels, slow motion, sounds, and more. So like, subscribe, comment if you need any help, and I'll see you in the next one. 25, it's supposed to be only 12 minutes long.